Welcome everyone to the May Python and Oracle Database Office half hours. But anyway, we're going to be talking about a few things which may or may not eventuate, perhaps. Standard safe harbor statement. So if you haven't seen it, we have a blog out here on blogs.oracle.com called Opal. I'll just type that into the chat for people who want to get that. Technically, it's kind of my blog, but we generally post things from the rest of the group out here. So Anthony, who's the creator and maintainer of the CX Oracle extension for Oracle Database, had this very long technical post out recently about batch statement execution. So batch statement execution is executing one statement with many data points. So it's not executing many different SQL statements, executing the one SQL statement. For example, if you're trying to insert a bunch of rows, the top is just some setup of tables. You can kind of understand that. But this is the way you may be doing it if you're not using this advanced method I'm going to talk about in the future. This is the old school way of doing it. So you can see that these are the data values. You've got many different data values that we want to insert into the database. And we've got the one statement. And in this old school method, we do a loop and loop around for each of those data values. That has the kind of drawback, and that is this thing we call a round trip. So round trip is kind of message passed from, in this case, CX Oracle into the database. Database has to wake up, network has to wake up, interrupts happen, memory gets loaded, etc., etc. And every time you do execute, that same thing's going to happen. So you get a lot of round trips to the database. If you instead use this executeMany method in CX Oracle, instead of that loop, we've lost the loop. If I scroll back down, so you can kind of see both. I can't quite see both, but if you scroll back down, you can see that here we have the loop calling execute multiple times. Here we just have to do one statement, so we only get one round trip. So this works for DML statements. So you get insert, as you can see here, you get updates, deletes, merges, and you can actually call PL SQL as well. So if you want to call a PL SQL procedure multiple times, passing in different parameters, you can do that. That's equivalent very much of calling the execute or the PL SQL multiple times. So the PL SQL procedure will get called multiple times, and side effects will happen if you've got triggers, etc., happening. That is really the gist of executeMany. It's really that simple. You can pass very large data sets, and let me just show you. This is from a set of slides for the Node Oracle DB driver, which has recently just implemented this function. So I'll just pop this up here for anybody who's kind of following along. This is for Node.js, not Python, but anyway, the underlying libraries which do all the work are the same between Python and Node. And so the results are sort of generally equivalent. I do cover my backside here and say your mileage may vary, and it obviously depends a lot on network speeds, the width of the data. And here I just had one number, one short string, but you can see that the number of microseconds that the execute, that loop style, the old style took was extremely large compared with the executeMany. I mean, just look at the difference in terms of microseconds there. So as you get up to large values, large numbers of data items, as you can see here, this is quite significant. The performance benefit is really, really quite drastic. Good drastic. And just to go on to one other example, this was a kind of remote database, not very remote, but still remote from me. And the performance difference wasn't as dramatic there. And I know that, and so I had a bigger data set as well. So I had like 3,000 bytes instead of just a few bytes for each row. And I know if you start adding in 32K byte varchars, you have a number of columns of those, and the difference may not be significant, but it's certainly worthwhile looking at. I mentioned PL SQL could be called, no surprises there. The executeMany method has a couple of extra, that's annoying, has a couple of extra options that you control data handling a little bit more fine-grained, as you can do if you're doing an old school execute, you get a lot of control. You can individually look at how each DML statement. Yeah, sorry about that. You can individually look at how each DML statement behaved, whether it had an error, whether it's actually affected a row, et cetera, et cetera, et cetera. With executeMany, we've got very similar controls on that, so you get pretty much one-for-one functionality. So DML row counts, yes. So here we're doing a delete. We're going to delete 3 times because we're doing executeMany. So we're doing delete for each of these data values, 10, 20, 30. And then at the back end, we might want to know how many rows actually had the ID 10, how many rows had 20. And by adding this extra, which I can't highlight as you saw, the extra array DML row counts option to executeMany, we then afterwards can actually pull out each of the row counts, and you get a kind of one-to-one correspondence. So this first value maps to the first data item, as you can see with the print output. Obviously, the values on the right depend on the input data. This is just our little sample data. We just happen to have 3 rows which had ID 20. How am I going on the font size on that? Is that a little bit small to see? That one does look a little small.
Not terrible, but it is definitely smaller.
Okay, yeah, whatever, we can bump that up. The other kind of scenario to handle, which execute, again, lets you have that immediate control because you're doing each thing individually, is when you have bad data. If you have noisy data, quite often you have very large data sets and you just want to get most of it in. You don't care if you're going to lose 1 or 2 HTTP requests in your Apache log or something like that. You just want to get the bulk of it in so you can do some statistical analysis or something like that. You don't want any of these errors to actually cause the whole transaction to abort. You want to get as much data in as possible. Let me go down to the executeMany example. And we have another option here. Oops, this is the case where it does abort, is if you just do it as a straight executeMany and you pass in your statement data, the first error that happens is just going to abort the whole operation. You're not going to get any data inserted. But there is a batch errors flag similar to the DML row counts flag you can pass in. And again, when you do this, you get a new method where you can call back and you get individual errors. And the key thing here is that the valid data will actually be inserted. The transaction will begin, and those valid rows will be available for you to commit or roll back as you desire. Or obviously, once you can, if you find you have errors, then you can go and look at this data. Errors row 3, 0, 1, 2, 3 has a problem. You can go back and decide whether you want to change that, munge that, delete it, whatever. That may make you decide whether you want to commit or roll back the whole operation. And the other little key trick here is that if you are in auto commit mode, there will be no commit if there are batch errors. There will be an auto commit if there are no errors. But if there are batch errors, the auto commit won't happen. Transaction is begun. You get to clean up and decide whether you want to commit or roll back explicitly. So you get more control in that way. DML returning statements are probably easier experimented with than described, but they are very powerful if you want to, say, do an insert and return all the row IDs and things like that. You can use it. Here we're doing a delete to show you the array behavior. And again, for each of these input key and input IDs, you can get a particular set of the child values returned back into the this output array, wherever it is.
That's it, yeah.
The child values, yeah. So this one I recommend you go and play with a little bit and just explore, because it's kind of gets a little tricky to work out whether you've got arrays of arrays and things like that. There was one little thing. Anthony, do you want to speak a little bit about this future?
Sure. So prior to 6.3, DML returning with executeMany didn't work as expected. You would get some very strange results. So that got added in 6.3, but we wanted to make sure that we didn't mess up CX Oracle 6.2 behavior. So that's why this new, on line 1, you can see there, CX Oracle __future__.dml red array val equals true. And what that does is it returns an array instead of a single value. And that means that you can get all of the rows that are returned for executeMany instead of simply the first row. And again, it gets a little bit complicated. You want to play with it because when we're talking about rows, you've got input rows for executeMany, and you've also got returning rows, and you can have multiple rows returned for each input row. So that's why that feature was needed.
Yeah, and you can start seeing here you've got nested arrays, and obviously the arrays coming out for each of those input values.
Yeah, as you can see on line 11 there, where it says input row 0, right?
Mm-hmm. Yep.
And then childvar.getValue on line 12, and then you see you're passing in the index value. So you're getting back an array. Whereas in the previous version, if you don't set that DML red array val, you would get back the particular element in the first row that was returned, or an error.
Cool. Yep. I guess the final thing, just in this sort of little warm-up, that we should cover is a sort of performance thing that you should know about if you're going to use this feature, executeMany, in CX Oracle. And that is just the way it works. We have to pass in consistent block of data. The memory has to be allocated in consistent lengths when we pass that down into the Oracle layers. And as you can see here, it's not consistent at the Python level. So we end up having to do some reallocation as we start seeing, as the code iterates through these, the internal driver code, the CX Oracle code internally iterates through this list which you pass in. We end up having to do reallocations until we find the maximum size that is used by default, that is. And so, things will work, everything will be happy, but it may not be as efficient as using this extra set input sizes option. So basically, my recommendation is to use this. Anthony's recommendation is just only use it if you need to use it. But since we know people cut and paste examples and put them into production, I kind of thought it was better to actually explicitly use it, so then at least people know what's going on. So the tuple here, it's not tuple, the two parameters here map to the types of the
first and second bind variables.
First and the second bind variable values, yep. So none we use because this is a number. You don't really need to specify anything. CX Oracle knows it's a number and can handle that. But for strings, then we need to, or down here, we specify a kind of upper limit. So really, by 20, we're saying that no string is going to be bigger than 20. In fact, I think this is probably less than 20. But as long as this is bigger than this value, then we don't have to do that reallocation. It does mean we're allocating 20 bytes for every data value, which is maybe a little bit bigger than you would have to do if you had an exact fit, but it does obviously allow some growth. So if you're not quite sure what data sizes are coming in, you have to make that choice. Do you let CX Oracle work out the data sizes, or do you oversize this value in terms of the pre-allocation of memory, which is going to occur? Pre-allocation of memory is going to be faster. So there's a little bit of a trade-off there, but that's just the way it is that it gets handled. So my recommendation, use set input sizes, but your mileage may vary.
Yeah, right. These are actually the samples that are found in the CX Oracle GitHub repository. I posted a link in the chat, so you can look inside there. But there's a few executeMany examples in here. One of the simplest ones is called bind insert. Right. Get clicking there. There we go. That's better.
Need to share, either share a screen, or do I need to move?
I'm sharing now, I believe.
Okay, yeah, I have got too many windows open. Okay, so that's hidden. Good, thank you.
You can see it?
Good. Yep, looks good.
All right, so here is the data here. So again, it's very, very simple. A number and a string, and we're calling cursor.executeMany. I've deliberately turned off commit so I can run it more than once, and then of course display the results. So if I run this, then you'll see that sure enough, it behaves itself and does what it's supposed to do. The other one that's more interesting is the batch errors one. This should look very familiar. As you can see here, here's our data to insert right here. And we've got our duplicate key and our parent does not exist. And I run it the old way without batch errors first to demonstrate what happens. And then I run it again afterward to show. And I also happen to show array DML row counts. And run these, then you can see here, we had 15 rows in the child table. We wanted to insert 8 of them. And we failed with the first primary key violation. So we happened to successfully insert 3 rows. Then we have, as you can see, a total of 18 rows. And then array DML row counts here, you can see this, the 1, 1, 1, those ones succeeded, 0 failed, 1, 1, 0, 1, right? And you can see there's 2 batch errors and we list them here. And then number of rows in the child table after successful insert is 21 now, because it actually managed to insert 6 rows. And I think there's one more. This one is very, very simple. It's much the same as the delete that we showed before. So here in the top here, I'm just showing that, you know, parent ID 1, 2, 3, 4, and 5 have 1, 3, 2, 5, and 4 rows respectively in the child table. And we're deleting parent IDs 2, 3, and 5. And then we can see that sure enough, it returns the number of rows deleted correctly. So you can take a look at those in the samples and play with them to your heart's content.
We kind of mentioned that we had the new support for, sorry, let me scroll it down so you can see 6.3 came out just a couple of days back. So we did mention we had this, you know, proper support for the DML returning statements. One other little thing we've been doing a little bit of work on, I guess, is session pooling. So the different ways to use the session pooling, like the connection pooling. And one of the ways people like to use it is as a pool of processes which are started, but they're not really authenticated to the database. And then they just use different username and passwords for each of those sessions in the pool. So previously, you can obviously have a pool of sessions which are all pre-authenticated, all use the same username and password. In fact, that's probably what most people do. But now we've got support for people who want to have different username and passwords. What else? You had Anthony, this is a kind of more CX Oracle-y, Python-y thing. Do you want to talk a little bit about the error object change if people aren't asking questions?
Yeah, sure. Really, the only thing that's happened is before it would return what's called a string exception. And now it returns one of those CX Oracle._error objects. Mm-hmm. It doesn't really behave much differently, but at least, and the reason it was requested is because that way, if you're processing the error, you can process it the same way. You don't have to go, well, oh, this is a string error and this is a object error. Mm-hmm. So that's the main reason for that. And
that's just across the board, right? So there's no extra future option or anything like that. Yep.
Nope. Yeah. Because it doesn't really make any difference if you're not catching the exception and processing the error object.
Mm-hmm. Yeah.